Hi guys. All right, after watching these videos, you should obviously see that we're working on classifying triangles and quadrilaterals. So I'm going to start out on these questions on triangles first, then quadrilaterals. A lot of this will look familiar to you because some of them I specifically picked because I just wanted to review things, and other ones because maybe we didn't do so good on certain types of questions, especially on certain ones with the quadrilateral. All right, on these that you can see, name that triangle. It's just going to give you information or specifics about a triangle. And you should just say what kind of triangle that would be. So I'm going to go over these four, that you can see right now. And then there's a couple on the next slide. All right, so number one says a triangle that has all angles that measure less than 90 degrees. Okay, so let's review something really quick because we can classify a triangle based on its angles or based on its sides. So let's review what we know about these angles and these sides for just a second. I'm going to kind of move this off to the side for a minute. So if we talk about classifying a triangle by its angles, okay? So if we're doing classifying by its angles, we have three options. One is if you see a right angle in the triangle, we know it's automatically going to be a right triangle. If we see an obtuse angle, which we know is greater than 90 degrees, if we see one obtuse angle there, then we know it's an obtuse triangle. Okay, remember, right angle is exactly 90, and obtuse is greater than 90, okay? So it would be from like 91 to 179 because it can't be a straight angle. All right, so the last one that we have is that we need to look at is smaller than 90, less than 90 degrees. So that one is an acute angle. So that's what we're going to use to classify our triangles by their angles. If you see a right or obtuse angle, it's automatically that type of triangle. For you to call it an acute triangle, remember all of them, every single angle has to be less than 90 degrees, which if we look at number one, that's what it says. So we're going to go back to that in just a minute. All right, the other way you can classify a triangle is by its sides. All right, so we know that if all sides are equal, then it's called equilateral. It's in the name. That's what we've talked about. Don't miss that one because we know it's in the name. If you have two sides equal, then that is like, remember, we have two eyes, isosceles. If we have no sides equal, then we know that one is called scaling. We've talked about no scales on a fish are the same, so we have scaling. All right, so you can actually name a triangle by both of these things. So you just have to look at the question and see what is it asking you to name it by. So let's look at number one again, and let's read what it says. A triangle that has all angles that measure less than 90 degrees. So the fact that it's saying all angles is important as well. All angles that measure less than 90. So that means that all angles are going to be acute angles, which means this is an acute triangle. All right, number two says a triangle that has all sides equal. All sides equal. We just talked about this. All equal sides is an equilateral triangle, but if you look at these, if you look at these options that they're giving you, the only one that we have acute is measured by an angle, so that doesn't even make sense. It's got to be the other one. So instead of them saying equilateral, they're saying equivalent. But really, most of the time, they call it equilateral, so know that. All right, number three. Number three says a triangle that has one angle that measures greater than 90 degrees. So that tells me that it has an obtuse angle in it, which also tells me that it has to be an obtuse triangle. Remember that it can only have one obtuse angle in it because we talked about all three angles in a triangle have to all equal up when added together 180 degrees. So you can only have one obtuse angle in a triangle. But once you see that, you know it's an obtuse triangle. All right, number four, a triangle that has exactly two sides that are equal. So if they have exactly two sides that are equal, we know, remember, you have two eyes, it is isosceles. All right, two more questions on triangles, then we'll get into the quadrilaterals. Number 5, a triangle that has one angle that measures exactly 90 degrees. So one angle that measures exactly 90 degrees. When we see that, we know we have a right angle. So we also know we have a right triangle. Remember, if it's specifically talking about angles, isosceles definitely shouldn't make sense because isosceles is classifying that triangle by sides. So you were only choosing really between A, B, and C, and once we knew we had a right triangle, had to be that one. All right, number 6, a triangle that has no sides that are equal. No sides that are equal are telling me it can't be equilateral. It can't be isosceles because that would be two sides that are equal. Obtuse doesn't make any sense because that's talking about angles and we're talking about sides. So it has to be a scalene triangle. All right, the rest of these questions have to do with quadrilaterals and different statements, different things, different types of questions that they ask about them. We know that quadrilaterals are a type of polygon. Polygons, remember, are any closed shape with straight sides, but a quadrilateral is specifically a four-sided figure. But you can also get very specific with different types of quadrilaterals. So I picked some of these questions because these were things that came off quizzes or tests that we took or benchmarks that we took that maybe we didn't do so well on, that we got a little confused on. So let's start by looking at this one. It says to study the figures that they give. Which characteristic do all three figures share? So let's look through the choices, okay? This first one says all three figures have four congruent sides. Well, remember we talked about what congruent means? Congruent means equal or the same size. So if I look at these shapes, I can clearly see that this first shape is a rectangle and these sides are the same, but these sides are not the same as those, right? So this specifically said four congruent sides, four equal sides. So these two are the same and these two are the same, but they're not all four the same. Same as this one. These two are the same and these two are the same, but not all four are the same. So we know that first one cannot be our answer. The next one, all three figures have four right angles. Well, remember, four right angles, like this corner right here, yes, this is a right angle. This is a right angle. But if I look at this angle right here, I can obviously tell that's smaller than 90 degrees, so it's not a right angle. This one right here is larger than 90 degrees, so it is not a right angle either. So I can tell that that one is not my answer. The next one, all three figures have two pairs of parallel sides. Remember, parallel sides, we've talked about it being sides that never touch. Okay, so we have here, they never intersect. So that one, these could be a pair of parallel sides. These could be a pair of parallel sides. All right, our last choice says perpendicular. Now we know, by definition, perpendicular lines intersect, and they also form 90-degree angles. Well, we've already kind of taken that out of the mix anyways because of the second choice. So we know that they don't all have four 90-degree angles. But we do know that they have all have two pairs of parallel sides because this is parallel to this side is parallel to this side, this is parallel to this is parallel to this, and same thing over here. This is parallel to this side, and this side is parallel to this side. So the only choice we have is that third choice right there. Okay, these kind of types of questions kind of threw some for a loop. So you're having to read, it says it's a choice matrix, so they're giving you choices that you got to click which ones it applies to each attribute. It says complete the choice matrix by selecting the attribute or attributes which best describes each shape. More than one attribute may be selected for each shape. All right, so we're going to kind of go down on this one. We're going to look at square, and we're going to go down the list and see, well, what makes sense for a square. So if I look at square, let's look at the attributes. Always has four equal sides. Absolutely. So we're going to put a check there. Always has four equal angles. Yes, they have four 90-degree angles. Always has two sets of parallel lines. True. Always contains at least one right angle. True as well, because it says at least one. So it doesn't necessarily mean that it has to have all four, but we know that a square does. So all of those attributes apply to a square. All right, so let's look at parallelogram. Always has 4 equal sides? No. It could look like a squished rectangle that has opposite sides equal, but not all 4. Always has 4 equal angles? Nope, not that one either. Always has two sets of parallel lines. That is by definition a parallelogram, so absolutely. Always contains at least one right angle? No, not necessarily, because remember, if you see a squished rectangle, then we know that it can look like a parallelogram. And the word always says that it's has to have it. It always contains a right angle. So that's not true. So there's only one that applies to parallelogram out of those attributes. All right, next one. Rectangle always has 4 equal sides. Not true. Always has 4 equal angles. That is true because a rectangle has to have 90 degrees in each corner. Always has 2 sets of parallel lines. Correct. Always contains at least one right angle. That is true. It actually contains 4 right angles, so that is a correct statement. All right, last shape, rhombus. Always has 4 equal sides. Yes, by definition it does. Always has 4 equal angles. Not true, because if we look at a rhombus, it's going to, some are going to be obtuse angles, some are going to be acute angles. So we can look at that kind of shape and see that that's not true. Always has 2 sets of parallel lines. Yes, that is true. Always contains at least one right angle. Not true. So only 2 are true for a rhombus. And that's it. All right, on this one, it's another choice matrix. You can tell I kind of chose a couple of these types of problems because we tend to have some issues with them. So on this one, it says a choice matrix is shown. Complete the choice matrix by selecting the appropriate category that describes each shape. So we're deciding on if each of these shapes in this column are either, if they're a parallelogram or if they're something else. So if they can be classified as a parallelogram, we'll click or check the first box. If they cannot, then they're going to be other. For example, a pentagon. A pentagon has 5 sides. So we know it can't be a parallelogram because a parallelogram has 4 sides. So we're going to mark other for a pentagon. A rectangle, by definition, a parallelogram just has to have 2 pairs of parallel sides. So a rectangle definitely is that. A rhombus also has that, so it can be a parallelogram. It's just a very specific type of parallelogram. A square also can have that. The last thing, a triangle. Again, a triangle has 3 sides, so it cannot be a parallelogram because the parallelogram has to have 4. So it is going to be other. All right, which of these can describe the figure shown? Select 3 that apply. So we need to make sure we are looking for 3. Obviously, it is a rectangle. You can tell that. It's also got opposite sides that are parallel, or 2 pairs of parallel sides. So it can be a parallelogram. It cannot be a rhombus because all sides have to be equal. So we know that's not it. It's definitely not a square because it also doesn't have 4 equal sides. So it's out. So the last thing is just a 4-sided figure, which is called a quadrilateral. So those are your 3 choices for this shape. All right, we know they love these questions, which statements are true. So we have to look through each one of these. We know we got to look and see. How many am I looking for? I'm looking for 3. So the first one says, all quadrilaterals are squares. No, all quadrilaterals are not that. That's not true. All parallelograms are quadrilaterals. That's true because a parallelogram has to be a 4-sided figure, and that's exactly what a quadrilateral is. So that is a true statement. All right, the next one, all rectangles are parallelograms. Remember, parallelograms, all they have to have is 2 sets of parallel sides, So that is a true statement as well. All rectangles are squares. No, that's not true because then that would mean they all have 4 equal sides, and that's not true. But the flip-flop of that, all squares are rectangles, that is true because by definition, a rectangle just has to have opposite sides equal, and they have to have 4 right angles. So a square does have that. So it is your 3rd choice. So those 3 are your answers on that one. All right, this one is another true statement that you're looking for. And if you look through each one, you can kind of mark out some answers that you know are not true. Actually, when you read the first choice, a figure that is a square is also a rhombus. That is your answer because A rhombus just has to have 4 equal sides. Well, a square obviously has that. It just specifically also has 4 right angles. So that is your answer, but I want to go through the other ones and tell you why the other ones are not your answer. A figure that is a rhombus is also a rectangle. No, because a rhombus does not have the right angle, so we can't say it's a rectangle. A figure that is a parallelogram is also a kite. No, because by definition, a kite looks more like a diamond, right? So it does not have those opposite parallel sides. Excuse me. A figure that is a kite is also a rhombus. And again, no, that's not true, because rhombus has to have all equal sides, and a kite might not. A kite might be something like this, where it has 2 short sides and 2 long sides. So that is not a true statement either. So it has to be the first one. All right, this one says determine which name describes the polygon. I only see one set of parallel lines, so it has to be a trapezoid. And actually, even though it says select all that applied, that's the only answer it could be. Once I noticed that there was only one pair of parallel sides, it can't be any of the rectangle, parallelogram, or rhombus. So there's only one answer on that one. All right, this one just asked for which one is showing quadrilaterals. So quadrilaterals just have to have 4 sides. So by telling that, we know it's not D. This one we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So it would be A, B, and C. So your answer choice would be that one. All right, this one is another choice matrix. It says select the characteristics that always describe each shape. So we're choosing between all equal sides or 2 sets of parallel sides. So if I look at a square, we know that it definitely has all equal sides. A rectangle does not always, so it is the 2 set of parallel sides. A rhombus has to have all equal sides, and a parallelogram does not necessarily. It just has to have 2 sets of parallel sides. Guess what? Another choice matrix. I just noticed that we weren't doing so well with these on as a whole, so that's why I'm giving you so many of this type. All right, so this one's just a true-false statement. So when you read these, a polygon is always a parallelogram. Well, that's not true, because a polygon can be any closed-side shape with straight sides. So it could be a pentagon, a hexagon, any of those. It does not have to be a 4-sided figure at all. So that's why we're marking false for it. A rectangle is always a quadrilateral. Absolutely, because a rectangle is a 4-sided figure. A rhombus is always a square. No, because a rhombus can look like a squished square, right? But it wouldn't have those right angles. So that one is a false statement. And the last one, a square is always a quadrilateral. Also, absolutely, because it has 4 sides. So it is definitely a quadrilateral. Okay, this type of question definitely trips some people up. So I wanted to put several of these in here and show you what it meant, because I think some were just kind of thrown off by the question itself. So if it says they want the most general to most specific, you have to remember that flow chart that we did where it started with a quadrilateral at the top and then it broke out to where it had a trapezoid and a parallelogram. All right, and then nothing else was under trapezoid. Then it broke into a rhombus or a rectangle, and the last thing was specifically a square. All right, so we're going to use that because we're going from the most general to most specific. Now, there's a word in these answers that are not on this flow chart, because remember, it's the most general of all. It is polygon, because that includes other things, because a quadrilateral is a 4-sided figure, but polygons can include a pentagon, a hexagon, an octagon, a triangle, any of those close-sided figures. So polygon actually had to go in the beginning, in the first place. So if I look at these answer choices, there's actually only one that has polygon in the front. And if you notice, as we go down this flow chart, the next choice is parallelogram, then rectangle, and then square. So you can tell it's going polygon, parallelogram, rectangle, square. So it definitely went from most general to very specific at the end. So that second choice is your answer. This is basically the same question, except they added a couple of things to it, but also it's still most it's the same thing as most general to most specific. This time it says least specific to most specific. So this is the same thing as saying most general. Okay, so we are going to put polygon. I'm just going to draw a line since I can't click and drag these like this question. Polygon would go first. All right, in this situation, I'm going to mark them out as I use them. So look at the 4 we have left. Quadrilateral is a specific 4-sided shape, so it would go next. All right, then a parallelogram says that it specifically has 2 sets of parallel sides. A rectangle now says that not only does it have 2 pairs of parallel sides, it also has 4 right angles in the corners. And then the last one is the very specific one. It has 4 equal sides and the 4 right angles. So that is the order from least specific to most specific. That's what that means by that question. All right, this one also I got lots and lots of questions about. So I want to kind of eliminate some answers. It says, which shapes can be labeled as parallelograms? Remember, they have to have 2 sets of parallel sides. So if I look at this example, I can see here's a trapezoid. It's definitely not your answer because it only has 1 pair of parallel sides. When I look at L, it definitely has 2 pairs of parallel sides. M is a rhombus. So L is a square. M is a rhombus, so it has 2 pairs of parallel sides. It's just going to turn differently. But when you look at N, it only has this 1 set of parallel sides. So it's actually a trapezoid too. So this one is out as well. But everything else works on this one. So L, M, O, and Q are your answers. So the last choice should have been your answer. All right, this one you're just trying to figure out what is supposed to be going in that space. So this is which shape can be used to complete the hierarchy correctly. So it's just showing you we're going from polygon to, remember, polygon's any closed-sided shape with straight sides, specifically to a 4-sided shape, then something in the middle, and then a rectangle. So we can kind of eliminate some things here. We know a square is going to be more specific than a rectangle. Can't be that. A kite would not even go, would only go in quadrilateral, but a rectangle wouldn't be underneath it. A trapezoid only has 1 pair of parallel sides, so it could not go there. So it has to be the parallelogram. All right, last questions. We're completing the hierarchy again. It says quadrilaterals, and then it's going down to the next one. We're saying what are always quadrilaterals? So on this one, we would put parallelograms. All right, then they're wanting us to break it down and say, what are always going to be parallelograms? Well, actually, we could have eliminated some answers from the beginning because we can see if we're talking quadrilaterals, that means 4 sides, right? So we know we can eliminate triangles, we can eliminate hexagons, pentagons. So these are only our choices. So and we also see rhombus right there. So we know that's not what we're going to use. And then we just use parallelograms. So we know that rectangles has to go in this spot right here. And again, if we learn that flow chart, that'll make that a whole lot easier. All right, that's the last question for quadrilateral. So now after you've watched all your videos on classifying triangles and quadrilaterals, please go take the 2 Mastery Connect assessments. They're both pretty short. I kind of split them up so that you get 2 good grades. Usually when we're doing triangles and quadrilaterals, overall you did really well. So I'm hoping that you can get 2 good grades, and if you don't do so well, I'll be looking at them and I'll let you know if I reset them, or if you notice it before I do, you can always send me a message, okay? Thank you guys so much for listening and watching and for working so hard. I really appreciate it, and I'll see you Monday from 12 to 1 on my live. Love and miss you always. Bye.